Hello, so in today's video, we're going to look at sketching graphs as modulus functions. So in the previous video, we looked at what the modulus of a number means. So if we remember, the modulus is just the size of a number. So for example, the modulus of -2 is just +2, for example. So just the size of the number. So how do we sketch graphs of y equals a function involving a modulus sign? How do we do that? So you got for examples here that we're going to look at today. So y equals modulus of x, sketching y equals modulus of 2x plus 1, sketching y equals 3 times the modulus of x minus 2, and sketching y equals 3 minus 2 times the modulus of 3 minus x. So we're going to sketch all of these graphs. Before we do that, let's just think about a few things to understand before we do this. So as we said in the previous video, so if x is a real number, then the modulus of x must be greater than 0. So yeah, the modulus again is just the size of a number. So if x is any real number, then this must be a number bigger than or equal to 0. And in fact, if you've got for example, these examples here, for example, if you've got like a linear function or a linear equation, a linear expression, I should say, really. So in fact, yes, if you've got a linear expression and you take a modulus of that, that's also greater than or equal to 0 too, for any real values of m and c. So again, we know that this is going to be greater than or equal to 0. And we know also because we know from GCSE that y equals mx plus c is just a straight line. So it's the equation denoting a straight line like that, or perhaps like that. So y equals the modulus of mx plus c. It's actually going to be a V shape. And essentially what it will look like is it will kind of look something like this, for example. So this is like your x-axis there. This is your y-axis. So it'll be a V shape which just touches the x-axis because this value there is greater than or equal to 0, as we've shown there, or as we've tried to explain there. So it will always be bigger than or equal to 0. So therefore, it will never go below the x-axis because it must be non-negative. So that's just something we're going to bear in mind. So let's consider this first example here. So y equals modulus of x. So the key thing to note is that when x is a number bigger than 0, so what does that mean? Well, it means that the modulus of x is equal to x itself. And that's because, I mean, for example, if you pick the number 2, well, the modulus 2 is the number 2, so that must be true when x is bigger than 0. How about when x is less than 0? So when it's less than 0, it's true that the modulus of x is actually equal to minus x. So it's like a little example here. If you pick x is -4, so a negative number, the modulus of -4 is actually +4, but 4 is -4, so this is actually minus x. So not minus x, just minus x. So yeah, that's just an example to show why that's true there. Okay, so when we actually go ahead and sketch this graph, so we've got the x-axis here, we've got the y-axis there. So sketching this, when x is bigger than 0, obviously 0 is there on the x-axis, the modulus of x equals x. So that means that y equals x when x is bigger than 0. So this is the graph we're going to get here, the y equals x line there. So, and again, that's because when x is bigger than 0, so on the positive x-axis, the modulus of x equals x. So it's just a y equals x graph from there. And then using the reasoning that we kind of tried to use back here, that we expect a V shape because of the positive nature of these modulus functions, we will actually get this kind of reflection over the y-axis, and this will be y equals negative x, and that's because of what we said here. So when x is less than 0, so a number less than 0, the modulus of x is actually equal to negative x. So this is the graph, basically y equals negative x on the left-hand side here. So in total, this V shape will be the final graph. So your sketch of y equals modulus of x is just going to be this V shape, y equals modulus of x, with your x-axis there and your y-axis there. So that's how we sketch this one. How about the next one? Okay, so y equals modulus of 2x plus 1. So again, the key thing to think about is that when this 2x plus 1 is bigger than 0, so in other words, equivalently, when x is bigger than -1/2, if you rearrange this inequality there, you'll get x is bigger than -1/2. just by rearranging everything there. So when x is bigger than minus half, then it must be true that y equals 2x plus 1. Why is this true? Because when 2x plus 1 is bigger than 0, the modulus of 2x plus 1 is just equal to 2x plus 1. So the same reasoning that we used back here with this first bullet point there. And the same is true down here. So when 2x plus 1 is less than 0, so in other words, when x is less than a negative half, it must be true that y equals negative of the 2x plus 1. Again, for the same reasoning, because when 2x plus 1 is less than 0, the modulus of 2x plus 1 is actually equal to the negative of that number inside the modulus signs. So the negative of that number there. So we just plug that in and we say y equals negative 2x plus 1. Expanding the brackets, we just get y equals negative 2x, negative 2. Sorry, that should be a negative 1 there, my bad. That's a mistake. Let me just swap the 1 in there. Yeah, so we get that. And then now we can plot the graph and try and do like a rough sketch. X there, y there. So when x is bigger than a negative half, so negative half will be there. So when x is bigger than negative half, the graph is y equals 2x plus 1. So perhaps a graph like this. Y-intercept of 1, because we've got y-intercept of 1 there, as we can see from the linear graph. And then when x is less than a half, it's going to be y equals minus 2x minus 1. So just the reflection of this, basically, this kind of V shape again. Obviously, the key thing is that this is only true, the left-hand side is only true when x is less than negative half. So we don't go down like that. That's not right. It's just a V shape again with this one. Again, similar to how we justified it back here. So yeah, that would be the second example finished. The next one, again, this is quite similar. So we've just got this time we've got a 3 there, a multiple of 3. But let's just focus on the actual modular signs first. So when when x minus 2 is bigger than 0, so in other words, when x is bigger than 2, just by, again, rearranging this there, then it must be true that the modulus of x minus 2 equals minus 2. So again, using the same kind of logic that we used there and that we used here. So yeah, that must be true there. So that means that y is equal to 3 times the positive of x minus 2. And so y equals 3 times x minus 2. And so y equals 3x minus 6 when x is greater than 2. And then a similar reasoning with this bullet point here when x minus 2 is less than 0. So in other words, when x is less than 2. It must be true that the modulus of x minus 2 is equal to negative of the x minus 2. Again, using this reasoning there and this reasoning down here. And then just by expanding the brackets, we get this result here that y equals minus 3x plus 6. So as you probably noticed, the signs of these terms basically negate themselves. So they're just the opposite signs, as we can see there with the 6 and the negative 6 and the 3 and the minus 3 x there. So you can actually just quickly get these results by just taking the negatives of what we get for our first bullet point or our first calculation over there. So again, how are we going to sketch this graph? I'll just do it over here. So again, our y-axis, our x-axis. So when x is bigger than 2, well, 2 is over there roughly, we're going to get this kind of graph here, y equals 3x minus 6, with positive straight line like that. And when x is less than minus 2, we get y equals negative 3x plus 6. So just a reflection of that in the line x equals 2. So the mirror reflection of that. And as we can see from here, we've got a y-intercept of 6. We can just actually put that in there. Okay, great. So that's our third one done. So then our last example, okay, so y equals 3 take away 2 times the modulus of 3 minus x. So first, let's not worry about these extra additional terms here, this 3 and this minus 2. Let's just focus on our modulus sign. Let's deal with this first. That's probably the easiest thing to do. So focus on this 3 minus x in the modulus signs. So when 3 minus x is bigger than 0, so in other words, when x is less than 3, it must be true that 3 minus x has a modulus equal to 3 minus x. So again, when this number inside the modulus sign is positive, well, that's just the same as the modulus of that number. So again, we're just using the same justification that we used before. So a little note here, actually, that I made just before we carry on. So when the modulus of 3 minus x is greater than or equal to 0, that means that minus 2 times the modulus of 3 minus x is less than or equal to 0 because of this negative number here. When you times a non-negative number by a negative number, you get a non-positive number, as we can see here. So with this graph, we're actually going to expect a pointy upside down V shapes, like a kind of pointy N shape there, because this time we've got the negative, which flips the graph upside down. So the minus sign just negates all of our Y values and makes them negative. So we're expecting this kind of shape. So let's just bear that in mind before we do any, before we go to the next part. So yeah, so when x is bigger than 0, sorry, 3 minus x is bigger than 0, then that means that 3 minus x is equal to the modulus of 3 minus x. So therefore, what we can say is that y is equal to 3 take away 2 times the modulus of 3 minus x, which in this case is just 3 minus x. And then when we expand the brackets and simplify this, we actually get this there just by expanding the 2 there with the 3 and the minus 2 with the minus x there. We do get this result here. So yeah, when x is less than 3, we get this graph there. And again, a similar reason for the opposite case. So when 3 minus x is less than 0, so in other words, when x is greater than 3, the modulus of 3 minus x is equal to the negative of 3 minus x, which is just minus 3 plus x. So again, just substitute that into our original equation. So y equals 3 take away minus 2 times by the negative of 3 minus x, which we just worked out here to be minus 3 plus x. And then, yeah, again, expand the brackets here, minus 2 times minus 3, minus 2 times x. And we do get this final result there. So y equals minus 2x plus 3 when x is less than 3. Okay, so, and again, this is actually very similar to the previous examples where the terms just negate themselves. So the terms are literally just the opposite of the previous calculation when we do with these modulus equations. So again here, 2x is the positive of minus 2x, and minus 3 is the negative of positive 3. So the signs just reverse themselves. So that's all that happens when we deal with these modulus graphs. So again, what will this look like? Okay, so we've got the y-axis there, the x-axis there. So when x is bigger than, when x is sorry, I think I made an error here. Have I made an error? Yes, I have. Sorry, this is the wrong sign down here. X should be greater than 3 down there. Okay, so when x is less than 3 over there, we've got the graph y equals 2x minus 3. Okay, so 3 is, let's just say 3 is there. Okay, so when x is less than 3, we've got this 2x minus 3 graph here. So 2x minus 3 has like a y-intercept of minus 3. And then, yeah, so when it is, I mean, if we just plug in x equals 3 just to work out where our y coordinate would be, so plug in x equals 3 to our original equation. So 3 minus 3 is going to be 0. So this term just goes to 0 there. So we just get 3. So actually, we need to plot 3 up there because we get a y coordinate of 3 when we plug in x equals 3 into our initial graph. So it's going to look something like this. The left-hand side, when x is less than 3, is going to be a straight line, something like this. And then when x is bigger than 3, again, it's just going to be the mirror image of that in the line x equals 3. So just a mirror reflection of that. So we're going to get this upside down V shape, and it's going to look something like this. And so that would be our graph of y equals 3 minus 2 times the modulus of 3 minus x. We could actually get this maximum point here just by, again, looking at the initial equation. So we know that the negative 2 times the modulus of 3 minus x, well, this can't be bigger than 0 for the same reason that we mentioned kind of over here. So this cannot be bigger than 0. So the maximum point of this part is just 0. So if we're adding 3 to 0, then the maximum point is going to be 3 there. So yeah, it's quite clear that actually our maximum y coordinate will be 3, and our x coordinate of that will be the point where this just goes to 0, and this will go to 0 when 3 equals x, because that goes to 0 when 3 equals x. X is 3. So that's our maximum point there. And so from there we can just do this calculation here to work out what our sketch will look like. So that's just a few examples of using modulus functions and sketching them, just to see what kind of shape we get when we sketch these graphs.